All right, today's just a practice day going through some of these graphs. Now, you could graph this one as a transformation. This is just the 1 over x graph that's been translated left 2 units. So if I want to get the graph first, I could do that. Move the vertical asymptote that was at x equals 0 over to x equals -2. Still has a y equals 0 graph. And then remember the original points for the 1 over x function are like this. So instead of the point being at 1, 1, it's right here. So -1, 1, and -3, -1. So that was me graphing based off of the parent function, 1 over x, and just shifting everything left 2. That's what we did way back in chapter 1. Or if you want to go through and figure everything out, you can. So x-intercept, there are none. There's nothing in the numerator to set equal to 0. Y-intercept, I guess I just sketched it in, but f of 0 would be 1/2. Okay, so that's pretty good. Vertical asymptotes, x equals -2. Horizontal, y equals 0. I don't really need extra points for that. Now, if I did it this way, then yeah, I would need the extra points that I plotted. For number 2, this graph, I can't use a transformation because there's an x on top, so it's more than just left 1, and I don't even know what this explanation would be. So we do need to go through the steps on this. I cannot factor and simplify anything. So I'm going to start with the vertical asymptotes. I know this is a little bit out of order, but from how I normally do things. So I'm going to kind of skip around. X equals -1 is the vertical asymptote. This is a tie. So y equals 2 over 1, y equals 2 is the horizontal asymptote. I like to sketch those in first, and then I like to do the intercepts. So 5 plus 2x would be equal to 0 for the x-intercept. That means that x equals subtract 5 divided by 2, -5 over 2. That's -2.5 right there. And for the y-intercept, you're finding c of 0. That's 5 over 1. So 1, 2, 3, 4, 5. And we don't need any extra points on this because remember, I'm only requiring you to have 1 point on each branch. And if your graph is divided into, I kind of think of this as like 4 quadrants, then you're going to have 2 branches and that's it. So you don't have to worry about whether the graph does something weird. It's just 2 branches and they are nice traditional curves. Nothing weird is happening. If you're ever unsure, of course, you can find extra points. Nice little warning on this one. Be careful, it needs to be 1 fraction first. Actually, it kind of doesn't. So again, this is a worksheet that we've used in past years where we didn't really talk about transformations. But now if you're going to use all the rules, then yeah, you've got to have this be 1 fraction first. But if you're going to use transformations, this is left 2, up 2. So don't forget about the parent function. You can use the parent function rules if it's just a number with no x over something simple like x plus 2 or whatever. So the vertical asymptote is at x equals -2. The horizontal would be moved up to y equals 2. It's still 1 over x plus 2. It's not 2 or 3 or negative. So the 2 points that are on the original branches of the parent function are still just going to be, I think of these as like, if this is the center, it's still just these first two corners here. So that's actually really easy. Now, say it's a quiz or something and I don't know, you're filling this in for points, you can still find this information. 0 equals 1 over x plus 2 plus 2. -2 equals 1 over x plus 2. Multiply x plus 2 over to this side. Solve for x. Add 5, or add 4 to get 5. Divide by -2. Is my x-intercept at -2.5? Yeah, pretty close. The y-intercept, 1 over 2 plus 2, 2.5. Did I do that? Yep. Vertical asymptote, horizontal asymptote. Now this one you would have to, if you're not relying on the up to, you would have to get the thing, like I said, if you're not going off your graph, you would have to get a common denominator there, but I'm just going to say it's y equals 2. And then I didn't need extra points. And you wouldn't either because you would have the intercepts on either part. Now, number 4 is not just a simple transformation. It would be if it were just 3 over x, but it's 3 over x squared. So I guess if you know the 1 over x squared graph, if you have that memorized, you could transform it. But this one, I think I will go ahead and make 2x squared minus 3 so that it's all over x squared. So this one I will get to be one fraction first. And I'm just going to use the rules that we talked about in the notes yesterday. All right, so start with the asymptotes. Nothing factors and simplifies, so there's a vertical asymptote at x equals 0. This is a tie. There's a horizontal asymptote at y equals 2, 2 over 1. Okay, x-intercept, when is 2x squared minus 3 equal to 0? When x squared equals 3 over 2, that's when x equals plus or minus radical 3 over radical 2, plus or minus radical 6 over 2. Well, gosh, how do I do that if I don't have a calculator? You can still estimate. Remember, radical 6, here's the reason we rationalize. I want to place this on a number line. I have no idea how to split up radical 3 over radical 2. Like, where does that go on a number line? Or I have a harder idea, I should say, of doing that. But radical 6, I know it's 2 point something because 2 squared is 4, 3 squared is 9, so it's 2 point something, right? Because radical 6 is between radical 4 and radical 9. And then I'm dividing that by 2, so that's going to become 1 point something. How accurate do I have to get? Well, I'm just graphing on here. I just expect you to be able to do plus or minus 1 point something. That's it. That is the reason that we rationalize problems. I can divide something by 2 and kind of semi-accurately place it. It's harder to be like, well, this is 1 point something and this is 1 point something smaller, and if I divide them out, it gets complicated. Okay, here's the good news about this. We're done. We don't need any extra points because the graph has 2 branches. They're both on the same side, which makes sense. It's a something over x squared graph. So yeah, I don't need extra points because I already know where the 2 branches lie. On this graph, nothing cancels, but I'm just going to make a note to myself. I can factor this difference of squares. I wouldn't want to forget about a vertical asymptote. So we've got those at plus or minus 2. This is another tie, so we have y equals 1 because I'm dividing out x squared over x squared. Remember, the rule for a tie is divide out the leading coefficients. For the x-intercept, if x squared equals 0, then x equals 0. The origin is the x-intercept, it's also the y-intercept. So that's the only annoying part. It doesn't, having the origin be the intercept doesn't give you a chance at having 2 points plotted. But even though I've said that you can go through a horizontal asymptote, if the horizontal asymptote is not y equals 0, you're not going to pass through it. So if you're unsure, you can plug in 1, and you would get 1 over 1 minus 4, so negative 1/3. So if you're not sure, if you want to be like double sure that the graph goes down, you could plug in some extra points, but that's not required. If you're not plotting the points, you just draw a smooth curve. Don't have to go crazy on it. Just draw a smooth curve and make it go down in both directions. I do need extra points beyond the plus or minus 2. So if I plug in 3, I get 9 over 9 minus 4 is 5. That's 1 4/5. So when I plug in 3, I get 1 and 4/5. And when I plug in -3, it's the same thing because, again, it's x squared over x squared minus 4. -3 is going to do the same thing that +3 does. This is an even function, so it has y-axis symmetry. And I need to be careful with my arrows there. This one I kind of started to curve up, so I'm not going to be too picky about it, but if you get really sloppy with these, this would get marked wrong. This one where I started to go up a little bit, I think that's okay. Now this is almost the same thing, right? The only difference is that it's x over x squared minus 4. So let's see what that does to the graph. I still have the same two vertical asymptotes, x equals plus or minus 2. The horizontal asymptote will change because now we're bottom heavy, y equals 0. And for my x-intercept, I still get x equals 0. Okay, so here's where it's annoying. In number 5, the point that I got from the x-intercept was below the horizontal asymptote, so I knew the rest of that branch was below. Here, because the horizontal asymptote is at 0, I don't know which way this goes, left and right, so I do need to plug in some points, or at least think pretty hard about it. So if I plug in -1, oh, y-intercept, by the way, is 0, 0 as well. If I plug in -1, I get -1 over 1 minus 4. -1 over -3 is positive 1/3. So to the left, you're going up, -1 and then up 1/3. Now, if you plug in 1, you're going to get the opposite, 1 over -3. So this is an odd function, right? If we plug in -x, we get the exact opposite of f of x. All right, so then let's see. We want to plug in 3. If I plug in 3, I get 3 over 9 minus 4, so I get 3/5. And this is an odd function, so if I plug in -3, I should just get -3/5. You can check the math on that if you'd like to, but it's kind of nice to remember about this whole odd and even stuff because, I don't know, it could save you a step or writing something out. Precious brain power or something. Okay, this is an odd function because if I plug in -x, I get -x over x squared minus 4. So yeah, that's odd. All right, next one. This is all factored out for me. So I can see clearly that the vertical asymptotes are 0 and 4. So 0, 4. And the horizontal asymptote, remember, you need to think of what this would be if you were to distribute. Doesn't matter what the other terms are. The leading terms would be 4x over x squared, which is bottom heavy, so y equals 0. For the x-intercept, if you set the numerator equal to 0, you get -1. So a point on a horizontal asymptote is okay, but it means we're going to have to plot a couple extra points just to see which side of the horizontal asymptote this graph falls on as we go to the left. For the for the y-intercept, if I plug in 0, I get 4 times 1 over 0 times -4. That's 4 over 0. That's undefined, which we should know because we have a vertical asymptote at 0. So, okay, so that makes sense. So we do have a lot of extra points to plot for this one. I want to finish off this branch on the left. So first, we need to know whether the graph goes up between this point and the vertical asymptote or down. So let's plug in -1/2. So you're getting 4. You don't have to work in these boxes, by the way. This is teeny tiny. 4 times 1/2 over, actually, yeah, I can't do that. I got to bring this down here. It's driving me nuts. Okay, so if I plug in -1/2, I get 4 times +1/2, because -1/2 plus 1, and then -1/2 times -1/2 minus 4. Do I care about the numerical value? Not really, but I mean, I'm going to do as much work as I need to here. I get 2 over a negative times a negative. That's positive over positive. The point is just that when you plug in negative 1/2, the graph goes up. What about to the left? Is the graph going to bounce at this -1? Probably not, because it's not a squared quantity. So that's another hint that this graph is probably going to go negative and then get closer to 0 and stay underneath. But if you're not sure, just plug in, let's plug in -2. 4 times -1 over -2 times -6. 4 over -2, -4 over positive 12 is -1/3. So yeah, when I plug in -2, I am at -1/3. So if you want to plot more points, you can, but this graph will eventually continue to approach the y=0 line from underneath without crossing through again. And then we need to know how the branch is in the middle and the branch on the far right. So in the middle, we're going to have some more work too. So I'm going to say I want to know where is, let's go right in the middle of it. Let's do 2. When we plug in 2, we get 4 times 3 over 2 times -2. 4 over -4 is -1 times 3. So we can go over 2 and down 3. And then we don't need any extra points in here because if we know the graph has to open down after that, because if it doesn't, I'm going to make it a little wider there. If it doesn't, then you just generated new x-intercepts, which can't exist mathematically, right? And our final extra point should be plugging in, let's say 5. If we plug in 5, we get 4 times 6 over 5 times 1, 24 over 5, so that's 4 4/5. So when we go out to 5, we're at positive 1, 2, 3, 4, and 4/5. So when do I care whether you find the number and when do I not care? I don't care if the number is just helping you figure out whether the graph goes to infinity or negative infinity, like which side of the vertical asymptote is it going to ride against. I do care if it's the only point that's being plotted on the graph of that branch. Okay, number 8. We can factor this a little bit. So there are vertical asymptotes at 2 and -1. The horizontal asymptote, this is bottom heavy, so we've got y=0. X-intercepts, if 3x equals 0, then x equals 0. That means that's also the y-intercept. We need to do some points, so let's plug in -1/2. -1/2. I need to know, does this graph go up or down from 0, 0? If we plug in -1/2, we get -3/2. And I like going into the factored version because I just care about the sign. -2.5 times 1/2. Negative on top divided by a negative on the bottom is positive overall. So this graph to the left from 0 goes up to infinity. Now it probably crosses through because x equals 0 didn't come from a multiplicity that's even, but just to be sure, I'm going to plug in 1. Then I would get 3 over -1 times 2. So yeah, -3 over 2. So 1 down -1.5. There's that. And then we need a point on the far left, point on the far right. So -2 gives me -6 over -4 times -1. That's -6 over +4. That's -3 over 2. So at -2, I'm down -1.5. That's enough to tell me that there's a branch that fits into this little corner here. I'm going to bet that the other branch is up here, but I want to be sure, so I'm going to plot 3. That's going to give me 9 over 1 times 4. 9 over 4, which is 2 1/4. So go over 3, up 2 1/4. Funny thing about 9 over 4, we tend to want to simplify it to 3 over 2 because they're perfect squares and whatever. But remember, you can't just square root as a method of simplifying, and they have to have a common number that divides into them. That's just a common little mistake thing that I see each year. Okay, number 9. 2 more of these. Number 9. Here we are, finally, to something that's top heavy. So it has a vertical asymptote at x equals 0, but there's no horizontal asymptote. This one's a slant asymptote because it's top heavy by degree 1. So that means that you need to do a bit of long division here. Remember to fill in your placeholder like we did in our bookwork. I need to multiply x by 2x to get 2x squared. That subtracts 0, drop down the 0x. I multiply x by 0 to get 0x. And maybe you can figure out at this point that you're finished. But remember, we don't care about the remainder. We just care about the y equals 2x part. And when you're sketching in your slant asymptote, sketch a tick mark for every rise over run point you can do. So this is 0, 0, and then it's going to be, the next point is going to be up 2 over 1. So you're kind of doing it like this. The reason you want to do that, mine's a bit wonky here, is because you need to know, sometimes the point that the extra point you plot is very close to that slant asymptote, and it's hard to tell which side it falls on, so you just need to kind of be as accurate as possible. For x-intercepts, is 2x squared plus 1 ever equal to 0? That's no, because this is always positive. So there are no x-intercepts. If you try solving for that x, you get an imaginary 0. There are zeros, but they're not x-intercepts because they're not real. There is no y-intercept because I can't plug 0 into the function. I get f of 0, I get 1 over 0, which is undefined. So we do just need some extra points here. We can easily plug in 1 or -1. So I'm going to plug in -1 to begin with. That gives me 2 plus 1 over -1. So -1, -3. So that's where it's important for me to know that the slant asymptote goes through the point -1, -2. So -1, -3 is below that. So when I sketch that little section in, I know it's got to fit into the narrow part of the x that I see. So the other point is going to be in the other narrow part of the x, but if we plug in 1, we get, again, 2 plus 1 over +1. So again, we had odd symmetry for this one, so 1, 3. This is an odd function. It's got that origin symmetry. Okay, and number 10, top heavy by degree 1. And I can do a bit of factoring, so let me take a look at that. It's not going to help me cancel anything, but just to get this thing fully worked out here. So we do have vertical asymptotes at plus and minus 2. And then we need to do a slant asymptote, not on our factored out version, but using the non-factored out version. So 2x squared plus 0x minus 8 needs to divide into x cubed. And remember, you've got to put in all these placeholders in case there's an extra term that makes it something other than y equals x or whatever. Okay. So we had this in our homework last night, I believe. What do we multiply 2x squared by to get 1x to the third? Well, if you need 2 to go down to 1, you multiply it by 1/2 x. So that's going to make this x to the third plus 0x squared. 1/2 times 8 is minus 4x. X cubes cancel, 0x squared. This is 4x. That's a remainder because it's a degree lower than what we're dividing by. We don't care about the remainder. The slant asymptote is y equals 1/2 x. which we will again plot as accurately as possible, meaning it goes through 0, 0, and then I'm going to put my next tick mark, rise 1, run 2, all the way across my little 10 by 10 grid on both sides so that it can be as accurate as possible. X-intercept is when x cubed equals 0, which is when x equals 0. Just like horizontal asymptotes, we can have an x-intercept on a slant asymptote. This is just guiding the end behavior. The y-intercept then is also 0, 0. And so we need to look at, this is another odd, I'm thinking back to that symmetry. This is odd symmetry because if I plug in negative x, I get negative x cubed over 2x squared minus 8. That's the exact opposite of g of x. So thinking about symmetry can help you do less math, basically. So the answer I get for negative 1 is negative 1 over 2 minus 8. Negative 1 over negative 6 is 1/6. Negative 1, positive 1/6. The graph goes up to the left. Now, without doing math, I know that 1 negative 1/6 has to be on the graph because I know this is an odd function. If you're not into the even odd thing, then plug in 1 and do the math. And then I'm going to plug in 1, 2, 3. That gives me 27 over 2 times 9, 18 minus 8. 27 over 10 is 2.7. That's above the slant asymptote. So I just sketch this to kind of fit the curve of that x shape there. And again, use the fact that this is an odd function. You don't have to bother plugging in negative 3. You should plot negative 3, negative 2.7, and fit that into the opposite curve. This has origin symmetry because it's an odd function. Okay, that's it for this worksheet. These are the most difficult graphs that we're going to have. Honestly, for your AP exam, I don't think you're going to be sketching a lot of graphs. I think you're going to be matching graphs and things like that. But, you know, we're expecting a little bit more. We've got a strong pre-calc program here, and you need to be able to sketch stuff like this just in case you've got to do this when you take a college course.